Time and space are like a fabric, like rubber, like a trampoline net. Turn this trampoline net into a pretzel and allow yourself to go backwards in time.
I think in this century, we'll probably pick up signals from an extraterrestrial civilization.
The revelations made by theoretical physicist Michio Kaku regarding the James Webb Space Telescope's JWST latest observations have sent shockwaves through the scientific community. The telescope, launched with the promise of peering deeper into the universe than ever before, has now brought forth findings that challenge one of the most cherished foundations of modern cosmology, the Big Bang theory itself. In particular, the detection of 750 anomalous galaxies in regions that were once considered beyond the known boundaries of the observable universe has forced many to re-examine long-held beliefs about how everything began. Before we start, smash the like and subscribe buttons for more updates. At the heart of this explosive revelation is the concept of what the JWST has actually seen. These 750 galaxies weren't just faint smudges or cosmic illusions. They were structured, mature, and in some cases, remarkably evolved for where they appeared in time and space. According to current cosmological models based on the Big Bang, galaxies at such enormous distances should appear primitive, loosely formed, and relatively dim. These galaxies, however, appeared much more developed than expected, raising the question, how could structures of this complexity have existed so soon after what was believed to be the beginning of time? The key detail that makes this discovery so paradigm-shattering is that these galaxies appear to be located in regions of space that, under current models, shouldn't even exist yet. The idea of the observable universe places a limit on how far we can see based on the time elapsed since the Big Bang, approximately 13.8 billion years. Light from anything beyond that point should not have reached us yet. And yet, the JWST has apparently detected light from formations well beyond this boundary, suggesting either a fundamental flaw in our understanding of cosmic distances or something even more radical, that the Big Bang was not the singular origin event it has long been thought to be. Michio Kaku, known for his contributions to string theory and popular science communication, has framed this discovery in provocative terms. While not claiming that the Big Bang theory is wholly incorrect, he asserts that it now appears dangerously incomplete. The presence of galaxies outside what we define as the universe undermines the assumption that time and space began in a finite moment. These objects challenge the narrative of a singular explosive birth from a state of infinite density and temperature. Instead, they suggest that either the universe is vastly older than previously believed, or that it may be just one bubble in a much larger multiversal framework. The idea of the multiverse has lingered in theoretical physics for decades, often discussed in the context of quantum mechanics or string theory, but until now it lacked observational support. What makes the JWST's findings so groundbreaking is that they may serve as empirical hints toward this once esoteric concept. If these galaxies truly lie outside the known universe, their existence could point to either overlapping cosmic realms or a staggered process of universal creation, where multiple Big Bangs occurred independently in different regions of an overarching space-time continuum. Another possibility is that our understanding of cosmic inflation is flawed. The inflationary model was introduced to explain the uniformity of the cosmic microwave background radiation and the large-scale structure of the universe. It posits a brief, exponential expansion of space in the earliest fractions of a second after the Big Bang. However, if mature galaxies already existed during or shortly after this inflationary period, the time window allowed for their formation becomes impossibly tight. It would mean that gravitational clumping, star formation, and galactic evolution all occurred much faster than known physics would allow, unless some form of pre-Big Bang activity had laid the groundwork beforehand. What's particularly striking about these 750 galaxies is their diversity. Some of them appear spiral in structure, others elliptical, and many display signs of active galactic nuclei, central supermassive black holes that power intense emissions. This degree of complexity implies not just rapid formation, but also prolonged periods of development. For this to be possible, either time flowed differently in those regions, or those galaxies are remnants from a previous cosmic epoch that somehow persisted into or re-entered our observable field. The implications don't stop at rethinking cosmic history. They extend into the very nature of physical laws themselves. If these galaxies were formed under conditions vastly different from our own early universe, it's conceivable that they operate under alternate versions of physics. Subtle deviations in constants, different particle interactions, or even unknown forces. The idea that the laws of physics may not be uniform across all of reality is a deeply unsettling one, challenging the principle of cosmological homogeneity that has underpinned physics for centuries. Furthermore, these findings reopen the debate about time itself. Time, in our current models, began with the Big Bang. If galaxies exist from before that moment, what does that mean for time's origin? One possibility is that time is not linear or singular but cyclical or branched, where different timelines coexist or follow one another in loops. Some speculative models, like conformal cyclic cosmology, have suggested that the universe undergoes infinite cycles of birth and rebirth, with each cycle leaving behind subtle traces in the next. The JWST's discovery might be the first tangible evidence that such a cycle is real. There's also the possibility that the current cosmological redshift models are inadequate. Much of the inference about distance and age in the universe is based on how much light from distant objects is stretched by the expansion of space, a phenomenon called redshift. If our assumptions about redshift are incorrect, these galaxies might not be as far or as old as they appear. However, that explanation feels increasingly unlikely given the convergence of multiple data points supporting the same conclusion. These objects shouldn't be where they are, and yet they are. Another unsettling consideration is the concept of an expanding universe itself. The discovery hints that space may not be expanding uniformly, or perhaps not at all in some directions. If these galaxies lie in a static or differently evolving region of space, then the expansion model may only apply to a part of the cosmos rather than the whole. This idea would completely rewrite the framework of general relativity as it pertains to cosmology, introducing anisotropies or discontinuities in the very fabric of spacetime. The James Webb Space Telescope was never designed to test the Big Bang theory directly, but its capacity to peer into the infrared spectrum with unmatched precision has allowed it to serve as an unexpected cosmic truth detector. As it continues to collect data, the evidence accumulates that the universe is far more complex, old, and structured than the simplified models of the early 20th century allowed. If the Big Bang model is a map, then JWST is revealing parts of the terrain that were previously uncharted, or even thought impossible. There is something poetic, almost mythic, about the idea that looking further into the void has uncovered not emptiness but order, ancient structures holding secrets older than the supposed dawn of everything. It forces a reconsideration of cosmic origins not as a singular explosion, but perhaps as an ongoing process, or a layering of realities, unfolding in a fractal pattern across infinite dimensions. Each new image from JWST might not just be a snapshot of a faraway star cluster, but a window into a different rulebook of existence. This discovery also forces reflection on the anthropic principle, the idea that the universe appears fine-tuned for life because observers exist within it. If galaxies are forming and evolving under different conditions outside our observable bubble, then the uniqueness of our universe is placed into question. Perhaps our universe is just one variant among countless others, each with its own trajectory, history, and potential for life. This doesn't diminish our place in the cosmos, but rather expands the scale and richness of the cosmic tapestry in which we find ourselves. There is an unmistakable irony in how scientific tools, built to confirm our theories, often end up subverting them. The JWST was launched to help understand early galaxy formation and dark matter. Instead, it may be ushering in the next revolution in cosmological thought, one that could make the Copernican and Einsteinian shifts seem tame by comparison. What it reveals might not be a final answer, but the opening lines of a new chapter in the story of everything. Yet perhaps the most profound consequence of this finding is philosophical. If the Big Bang no longer represents the beginning, then what does? Are we fated to forever chase the ghost of a starting point that doesn't exist? Or are we finally approaching a level of understanding where beginnings and endings are human illusions, useful for storytelling, but irrelevant in the boundless, recursive, evolving totality of the cosmos? As science inches forward through discoveries like this, the boundaries between physics and metaphysics blur. The tools of astronomy start to resemble instruments of philosophy. We are no longer just mapping stars and galaxies. We are questioning the fabric of reality, of existence itself. The 750 galaxies seen by JWST may not just rewrite our history. They may force us to redefine what a universe is, where it starts, and how far beyond it truth really lies. Such moments in science are rare, when observation collides so forcefully with expectation that something has to give. The Big Bang has served as a foundational story for generations of physicists, but every story has its limitations. With the data pouring in from the farthest reaches of time and space, a new story is beginning to write itself. Not one of singularity and explosion, but one of multiplicity, recursion, and unfathomable depth. The discoveries don't just call for new physics, they demand new imagination. What we're glimpsing through the JWST is more than just ancient light. It's a challenge to think bigger, beyond singular narratives and into pluralistic, layered understandings of reality. The Big Bang may not be dead, but it's no longer alone. And in that widening cosmic horizon, a far more intricate universe begins to unfold. One that defies simplification and promises wonder far beyond what we ever thought possible. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Big Bang debunked by James Webb Telescope findings? We want to hear from you. Thank you for watching and see you next time.